In this topic, titration method is applied to determine the concentration of citric acid in a fruit juice. What is citric acid? Citric acid is a weak organic acid that can be found in all citrus fruits such as lemons and orange. It has a monoclinic crystal structure and widely used in food industry as a natural preservative with an acidic taste, which is sour. However, citric acid can be harmful to us if it is consumed too much and leads to negative effects to our body. Since the properties of citric acid is acidic, it can cause teeth erosion, which is dental problems. Meanwhile, for some people it can lead to stomach pain, bloating, and nausea. Therefore, basic analytical method, which is titration, is applied. What is titration method? Titration method is the quantitative analysis technique that used to determine the unknown concentration solution from the known concentration solution. To perform titration, titrants and analyte should have different pH. If the analyte is acid, then the titrant should be base and vice versa. This method involves titrants, analyte, indicator, and endpoint. The type of this titration is titration of strong base with weak acid, sodium hydroxide solution as the titrant, while the fruit juice as the analyte.
In this part, I'm going to talk about 4 industries that use titration. The first one is water industry. They use it in water engineering, potable and wastewater treatment plants, water purification, and more. It is used primarily to test water and various parameters such as pH level and chemical content. The second one is chemical engineering. Titration can help with various aspects of chemical manufacturing, for example, quality control, reverse engineering, and environmental sustainability compliance. For quality control, some manufacturers perform acid-based titrations when testing the concentration of reagent like stearic acid. The third one is food products or food industry, where they use it to check on the quality control of foods products to determine the levels of antioxidants and oxidants present in foods. It is also used to improve the shelf life of foods and food quality. The last one is factory industry. Titration is extensively used in manufactures of biodiesel fuel from vegetable oil, where the acidity of waste vegetable oil from various sources, such as fast food, is determined to the extreme.
Some apparatus that we use are burette, retort stand, pipette, conical flask, funnel, and white type.
For the procedure, first we must fill the burette with the NaOH solution using a funnel until it reaches the 0 ml mark. After that, record the initial volume of the NaOH solution in your data table. Then, 20 ml of the diluted lemon juice is transferred into the clean conical flask using a pipette. Add 6 drops of phenolphthalein indicator into the conical flask. Then place the conical flask under the tip of the burette and place a white tile under the conical flask so that we can see the color change more clearly. Next, the stopcock is turned on to start the titration process and the conical flask is continuously swirling. When the endpoint is near, slow down the titration by adding drop by drop the NaOH solution. It continues until 1 drop of the NaOH remains for at least 15 seconds. Finally, read the final volume of the burette and write it in your data table. Repeat the titration twice more.
The result for titration require initial burette reading, final burette reading, and the volume of solution we titrated. The burette reading must be read at the bottom of the Meniker's curve to avoid parallax error. The volume of solution we titrated can be obtained by subtracting the final burette reading with the initial burette reading. The titration can be stopped if there are differences of plus minus 0.10 ml in the volume of solution we titrated. Therefore, the titration are stopped after the third trial because the volume of sodium chloride titrated in the first and third trial is 0.10 ml.
Concentration of citric acid. We already know from the balance equation that 1 mole of citric acid equal to 3 mole of NaOH. In trial 1, 0.00174 mole of NaOH equal to 0.00522 mole of citric acid. In trial 2, 0.00181 mole of NaOH equal to 0.00543 mole of citric acid. The last trial, 0.00173 mole of NaOH equal to 0.00519 mole of citric acid. For the next trial, the concentration of citric acid in diluted juice in trial 1 is 0.261 equal to 2.61 in original juice. In trial 2, 0.272 in diluted juice equal to 2.74 in original juice. In the last trial, 0.260 in diluted juice equal to 2.60 in original juice. In conclusion, this experiment aimed to determine the concentration of citric acid in fruit juice through titration. By titrating lemon juice samples with a standardized NaOH solution, the concentration of citric acid can be calculated. Citric acid may be good for our body, but if taken in a large amount, it may be harmful for our health. It can cause skin irritation for those who have sensitive skin, or when it touches our skin for a long period of time. Medicine with citric acid also cause some side effects, such as chest pain and fatigue.